Okay, welcome class. Students, in the previous class or in the previous video of class 9, we discussed about the second law of motion, and I have shown you the derivation, how logically the force can be calculated. Okay, in the second law we have learned that, but there is another dimension of Newton's second law, which is momentum. Okay, students, what is momentum? We have to answer that. How can we say? Momentum is nothing, it is just a property of only a moving body. Mark my words. Momentum is a property of only moving body having two factors, mass and velocity. Alright? Momentum is a property of a moving body by virtue of both its mass and velocity. So momentum can be carried in the moving body only. Okay? It cannot be that suppose that any body is at rest position. What will be the momentum of that body? We will say that nothing. It is zero. Absolutely zero. Okay? Every moving body possesses momentum due to its mass and motion. Students, Newton used this term momentum as a quantity of motion. What term he used? Quantity of motion. That what is the magnitude? What is the quantity? What is the quantity in motion? Quantities of motion. That term is later known as momentum. And what definition today we study? We study the definition that momentum is defined as the product of mass and velocity. Alright? So, proper definition for today's time is momentum of a body is defined as the product of mass and velocity of a body. Mathematically, this is the definition, the proper definition. Alright? Mathematically, momentum, we should know that it is denoted by P. Momentum is denoted by P. Denoted by P. Alright, students? As well as some other characteristics, momentum is a vector quantity. Momentum is a vector quantity. In saying vector quantity means what? Having magnitude as well as direction. It has both magnitude plus direction. This is point number 1, this is point number 2. In point number 3, these are the characteristics we can say about the momentum. The SI unit, okay? The SI unit means what? System International Unit. SI unit of momentum is kg meter per second. Why? Because when we write mathematically, P equal to mv, okay, P vector will be better denotation to write the momentum because it is a vector quantity. So the velocity is, so P vector equal to mv vector. Alright, students? That is why unit of mass. What is unit of mass? Suppose I have to get the unit of momentum. P vector. So what will be here? Unit of m into unit of v vector. Right? So what is unit of m? It is kg. And what is unit of v vector? That means velocity is meter per second. So this is the SI unit for momentum. I hope you have understood this one. Now, there will be another fourth point, we can write momentum of a body at rest is zero. Momentum of a body at rest is zero. For example, it is any object which is at rest, we can say that there's a no momentum, because momentum is a property of a moving body. This characteristics is only applicable to the moving body, not for the body at rest. Students, number 5 point, fifth characteristics. Momentum P is directly proportional to mass of a body. Okay. Consider that velocity V is fixed. V is fixed. So we know that momentum is directly proportional to the mass of body. If mass is doubled, suppose if mass is doubled, so the momentum is if mass is halved, alright, so the momentum is that means it is directly proportional to m. Momentum is directly proportional to m, but the condition is there. What is the condition? Velocity must be constant. Velocity must be fixed. Alright. The number 6 point, we will say that momentum is also directly proportional to the velocity of a body. Here we have to consider that mass is constant. Okay. That means if velocity is doubled, then momentum is double. If mass is half, then if velocity is half, then the momentum is also half. It is directly proportional to the velocity of a body. How? What could be example? We can say that a cricket ball bowled at high speed may hurt the batsman. Right? Yes or no? A cricket ball bowled at high speed may injure the batsman severely. There's one batsman who used to play from Australia, and that batsman was badly hit by the bowler, and it was the first class match I can remember, and right then and there the batsman was declared dead because of a very heavy injury that he faced, okay, on his head, and it causes, the whole of incidents causes death for him. So we can say that surely a cricket ball bowled at high speed may injure the batsman severely. Alright, because having the high speed, having the great speed, that means having the high momentum, great momentum. Okay, so these are the characteristics of momentum. Now I am going to show you the relation between the momentum and Newton's second law. Okay. The next topic, after doing the momentum, this is the another topic which must discuss. What is the discussion topic? A relationship between momentum and Newton's second law. Newton's second law. By Newton's second law, by Newton's second law, we concluded one relation, F equal to ma. Correct? Yes or no? F equal to ma, this relation we have established and we discovered, founded in the Newton's second law. This is the equation number 1. Let us consider it as equation number 1. One more relation that we have, A equal to B minus u by t. Do you remember? I have discussed that acceleration is nothing, it is the rate of change in velocity. So it is equation number 2. Let's see, students, what I am going to do on substituting equation 2, on substituting A in equation 1. What the new thing that I am going to get? F equal to m into A. In place of A, we can write B minus u by t. Okay? F equal to m into B minus u by t. Now, F equal to what? mb minus mu by t. Okay? So, mb minus mu is what? See, m is mass, b is velocity. Alright, this velocity is final velocity in context of acceleration. This is mass, this u is initial velocity. Alright, so this is momentum, this is also momentum. This is for final speed and this is for initial speed. So this can be called as a final momentum, this can be called as a initial momentum. Momentum is what? The product of mass and velocity. So here we can write what? Final momentum minus initial momentum by time. So in better way we can write force equal to Pf, that means final momentum, minus Pi, initial momentum by time. So this relation also gives us one definition. What is the definition we can call now? We can address or define force is defined as the rate of change in momentum. A rate of change in momentum of a body. So this is one more definition for force. Alright. So this is the relationship between momentum and Newton's second law. I hope you have understood. This is easy, simple. Now moving on to one more dimension of Newton's second law. What is that? Let's see. The another one is called impulse. Impulse of a body. Not pulse, impulse. Impulse is a force which acts for a short interval of time. It is a force acts on a body for short interval of time. Short interval of time. Impulse is itself denoted by I. Okay. Impulse is denoted by I. And there are two factors which are responsible here, force and time. So we can write I equal to F into T, where I equal to impulse, F equal to force, and T equal to time. Alright, so SI unit will be SI unit of impulse. The Newton is the SI unit of force, so Newton I am writing here. SI unit for time is second. So Newton second is SI unit for impulse. Just now, in case of relationship between the momentum and Newton's second law of motion, we have reached to one point. What was the point? What was the relation? The relation was F equal to Pf minus Pi by time. Do you remember this? Yes. This was the concluding relation which just we derived out to the expression. So students, we can write as well Pf minus Pi equal to, if T will be sending to the left hand side, it will give as a product F into T. Now F into T is what? It is impulse. Alright? F into T is what? Impulse. So we can write Pf minus Pi equal to I. So here one more relation we are seeing, we are looking at. So there will be other definition of impulse of a body. Impulse of a body is defined as the change in momentum of a body, and the change in momentum of a body. Alright, so this is we are ending with the Newton's conceptual matters. Now in the next class we will discuss more about the applications from the daily life of Newton's second law. So please update your notes, students, and please send your copy, virtual copy, that means images of the updated notes. Thank you very much.